Dear students, Namaste, good morning to you all, and also welcome to another session of online mathematics class. In the previous session, we have learned the distance formula and we have learned how to calculate the distance between 2 points. In today's session, we shall discuss some detailed application of distance formula in coordinate geometry. Let us move on to the topic. Let's have a quick recall about the properties of quadrilaterals. Quadrilateral means a geometrical shape, a closed geometrical shape having 4 sides. And these 4 sides, I am just classifying it into 2 categories. The first category is all 4 sides are equal, and the second category is 2 pairs of opposite sides are equal. I just classified into 2, that means 4 sides are equal. Next category is opposite sides are equal. And a geometrical shape having all 4 sides are equal means there are 2 chances. It can be a rhombus or it can be a square. And the difference between the rhombus and the square is, in case of a square, all angles are 90 degree. In addition to that, the diagonals of a square are also equal. And in this second category, that is 2 pairs of opposite sides are equal means there are 2 chances, 2 possibilities. The first one is it can be a rectangle or it can be a parallelogram. And again, here the difference between rectangle and parallelogram, it is quite clear. In case of a rectangle, all angles are 90 degree. And in case of a parallelogram, the opposite angles are equal. In addition to that, the rectangle is having an additional property, that is, in case of rectangle also, the diagonals are equal. So, hope it is clear. Once again, the quadrilaterals means a geometrical figure having 4 sides classified into 2 based on their sides. All sides are equal, opposite sides are equal. And in case of all sides are equal, there are 2 possibilities. It can be a rhombus or it can be a square. In addition to that, square is having another property, that is diagonals are also equal. And in the second category, 2 pairs of opposite sides are equal. It can be a rectangle or it can be a parallelogram. And a rectangle and a parallelogram, the angle properties, when you check, the rectangle is having all angles 90 degree and the parallelogram is having opposite angles are equal. And in addition to that, the rectangle is having another property, that is the diagonals of a rectangle are also equal. Now we shall discuss how to use distance formula in an examination point of view. When you check the board examination questions, there are 4 types of questions usually used to ask. They used to give you 4 pairs of points or vertices, and you may be asked to verify whether the given points forms a rhombus or the given points forms a square or a rectangle or a parallelogram. So here we shall discuss how we will prove whether it is a rhombus or a square or a rectangle or a parallelogram. In case of a rhombus, we must prove that all 4 sides are equal. And in case of a square also, we have to prove that all 4 sides are equal. And in case of a rectangle, first we may have to prove that 2 pairs of opposite sides are equal. And in parallelogram also, same thing, that is 2 pairs of opposite sides are equal. Once again, in case of rhombus, we have proved that all 4 sides are equal, and that is enough. And finally, you can come to the conclusion that the given points forms a rhombus. Means if it is asked to prove a rhombus, you have to prove that all 4 sides are equal. And in case of a square, in addition of all 4 sides are equal, you must prove that the diagonals, 2 diagonals are also equal. And in case of rectangle also, same thing. First you have to prove that 2 pairs of opposite sides are equal. In addition to that, you have to prove that 2 diagonals are also equal. And that is enough for square and rectangle. And in case of a parallelogram, 2 pairs of opposite sides are equal. That is enough, and we can come to the conclusion that the given points forms a parallelogram. Once again, in short, for proving rhombus, you have to prove all four sides are equal, and in case of a square, you have to prove all four sides are equal and two diagonals are equal, and in case of rectangle, you have to prove two pairs of opposite sides are equal and diagonals are also equal, and in case of parallelogram, you must prove that two pairs of opposite sides are equal. Now we shall discuss question number 5 of exercise 7.1. The question is, in a classroom, four friends are seated at the points A, B, C and D as shown in the figure. Chamba and Chameli walk into the class, and after observing for a few minutes, Chamba asks Chameli, "Don't you think ABCD is a square?" Chameli disagrees. Using distance formula, find which of them is correct. So here there is a given diagram. In that four friends A, B, C and D, they are sitting at these corners that is marked with A, B, C and D. So from the diagram we can just point A, B, C and D. So the coordinates we have to write, that is A is 3 and 4, B is 6 and 7, C is 9 and 4 and D is 6 and 1. So we have just pointed out the coordinates of A, B, C and D. A is 3, 4, B is 6, 7, C is 9, 4 and D is 6, 1. Now we have to write the distance formula, as we have learned the distance formula, that is the root of x2 minus x1 the whole square plus y2 minus y1 the whole square. And our aim, our task is to prove or check whether ABCD is a square or not. Just we have revised that how we have to prove the given points forms a square or not. So let us take the first point, that is A and B, first pair of points. A is 3, 4 and B is 6, 7. And let us copy down x1, y1, x2, y2. x1 is 3, y1 is 4, x2 is 6, y2 is 7. So by using distance formula, let us calculate the distance AB. That is x2 minus x1 the whole square. x2 is 6 minus 3. 6 minus 3 the whole square plus y2 minus y1. y2 is 7 and y1 is 4. That is 7 minus 4 the whole square. Go for the calculation, that is 6 minus 3 is 3 square, 7 minus 4 is 3 square. So root of 3 square plus 3 square, that is root of 9 plus 9. That is equal to root of 18. And 18 we can split it into 9 into 2. And 9 is a perfect square and 3 will come out and root 2 remains same. Units. So 3 root 2 units is the length or the measure of distance of AB. Now we have to move on to BC, B and C. We have copied down the point B and C, and as before we have to write x1, y1, x2, y2. Then we have to go for calculating BC. That is x2 minus x1 the whole square. x2 is 9, 9 minus 6 the whole square plus y2 minus y1. y2 is 4 and y1 is 7. That is 4 minus 7 the whole square. Then when you go for the calculation, 9 minus 6 is 3 square. Then 4 minus 7, that is minus 3 square. When you calculate, 3 square is 9. Again minus 3 square also 9. So 9 plus 9, that is equal to 18. And 18, as before, here we have done the calculation. Same calculation only. Finally we can write it as 3 root 2 units. The same calculation. Next move on to calculate the length of CD. For that we have to write the point C and D. Then we have to copy down the values of x1, y1, x2, y2. By using the distance formula, we have to calculate the length of CD. That is x2 minus x1 the whole square. x2 is here 6, x1 is 9. That is 6 minus 9 the whole square plus y2 minus y1. y2 is 1, y1 is 4. So 1 minus 4 the whole square. Go for calculation. 6 minus 9 is minus 3. 1 minus 4 is also minus 3. So minus 3 square plus minus 3 square. Calculation again, that is minus 3 square is 9. Again minus 3 square also 9. So 9 plus 9, that is equal to root of 18. Root of 18 we can split as root of 9 into 2. Then this 9 is a perfect square, that will come out as 3 root 2 units. So the length of CD is 3 root 2 units. Next we have to go for calculating the length of AD. For that, point A and point D is written. Then we have to go for x1, y1, x2, y2. Then after writing these coordinates, let's use the distance formula to calculate the length of AD. That is x2 minus x1. x2 is 6, x1 is 3. 6 minus 3 the whole square plus y2. y2 is 1, y1 is 4. 1 minus 4 the whole square. 6 minus 3 is 3. 1 minus 4 is minus 3. So 3 square plus minus 3 the whole square. Next we have to calculate, that is 3 square plus 3 square, that is 9 plus 9, that is equal to root of 18. As before, calculation root of 18 we have to write it as 9 into 2. Then we have to go for answering like 3 root 2 units. Same calculation like before. Next we have to go for calculating the length of AC. So A34 and C94 are the points. Just write down x1, y1, x2, y2. Go for using the distance formula to find the length of the diagonal AC. For that, x2 minus x1. x2 is 9, x1 is 3. So 9 minus 3 the whole square plus y2. y2 is 4, y1 is 4. So 4 minus 4 the whole square. Expand it, that is 6 minus 3 is, 9 minus 3 is 6 square. 4 minus 4 is 0 square. So 6 square plus 0 square, that is root of 36. Then root 36 we know that it is 6 units, that is the length of the diagonal AC. Next move on to another diagonal, that is BD. B67 and D61 are written. x1, y1, x2, y2 is written from the given points. Then use the distance formula to calculate the length of the diagonal BD. That is equal to x2 minus x1. x2 is 6, x1 also 6. So 6 minus 6 the whole square plus y2 is 1, y1 is 7. That is 1 minus 7 the whole square. Further calculation, that is 6 minus 6 is 0. 1 minus 7 is minus 6. So 0 square plus minus 6 square. That is equal to root of 36 only, because 0 square is 0, minus 6 square is 36. So root 36, that is equal to 6 units. So when you check the length of the sides and the length of the diagonals, we can come to the conclusion that side AB, side BC, side CD, side AD all are having the same length, and also diagonal BD, diagonal AC also having the same length. So we can write like this: AB equal to BC equal to CD equal to AD, and diagonal AC equal to diagonal BD are of equal length or same length. Therefore, we can tell that ABCD is a square, and hence whose statement was correct? It was the question. Chamba was correct. That is the conclusion of the question. Now move on to question number 6. The question is, name the type of quadrilateral formed, if any, by the following points and give reasons for your answer. The points given to you are -1, -2, 1, 0, -1, 2, -3, 0. So before start solving this question, let us have a rough diagram. Just you can draw any four-sided shape and just plot the points or vertices A, B, C and D as you wish, because I just have taken here the vertices as A, B, C and D. If you feel any inconvenience, you can choose some other alphabet. It's not a problem. And just go for the assumptions, that is, let the points -1, -2, 1, 0, -1, 2 and -3, 0 be representing the vertices A, B, C and D of the given quadrilateral respectively. Then you have to write the distance formula. We know the distance between the 2 points is given by the distance formula, that is root of x2 minus x1 the whole square plus y2 minus y1 the whole square. Then first of all we have to go for finding the length of the side AB. For that we have to write point A and point B. Then we have to go for writing x1 y1 x2 y2. By using the distance formula we can find out the length of AB. AB equal to root of x2 minus x1. x2 is 1, x1 is minus 1. So 1 minus minus 1. Minus minus 1 is plus 1. So 1 plus 1 the whole square plus y2 minus y1. y2 is 0, y1 is minus 2. So 0 minus minus 2. Again minus minus is plus. 0 plus 2 the whole square. So for the calculation, that is 1 plus 1 is 2 square, 0 plus 2 also 2 square. That is equal to root of 2 square, we know that it is 4. Again here 2 square, we have got the answer 4. That is equal to root of 4 plus 4, we will get the answer 8. So now 8 we have to split, that is equal to root of 4 into 2. And this 4 we can write as square root of 4, we know that it is 2. So we can write it as 2 root 2. 2 root 2 units is the length of the side AB. Next we have to move on to the another side, that is BC. From the diagram we can choose BC. We have to write the point B and point C. Next we have to go for calculating x1 y1 x2 y2, or just simply write down the coordinates from the given points. Then we have to go for applying distance formula to calculate the length of BC, that is equal to x2 minus x1 the whole square. x2 is here minus 1 minus 1 again. So minus 1 the whole square plus y2 is 2, y1 is 0. So 2 minus 0 the whole square. So minus 1 that is we will get the answer minus 2 square. 2 minus 0 we will get it as 2 square. Calculation part again, minus 2 square we know that it is 4, and again 2 square we will get 4. So total 4 plus 4 we will get 8, and the same calculation as before we have to write it as root of 4 into 2, and the root 4 will come out as 2. Inside the square root only root 2 balance. So 2 root 2 unit is the length of the side BC. Next we have to go from the diagram, it is CD. So we have to write down the points C and D as before. Write down x1 y1 x2 y2. Then go for calculating the side CD by using distance formula. x2 minus x1. x2 is here minus 3 minus minus 1. Minus minus 1 is plus 1. So minus 3 plus 1 the whole square plus y2. y2 is 0 minus y1 is 2. So 0 minus 2 the whole square. Do further calculation. Minus 3 plus 1. Minus 3 plus 1 is minus 2 square. 0 minus 2 also minus 2. So minus 2 square plus minus 2 square. Minus 2 square we know that it is 4. So finally 4 plus 4 we have got. 4 plus 4 is root of 8. 8 we have to split like before, root of 4 into 2. Then root 4 will come out as 2. So 2 root 2 unit is the length of the side CD. Now from the diagram we have to find out the length of AD. So we have to note down the points D and A. D minus 3 0 and A minus 1 2. As before we have to write x1 y1 and x2 y2. Then we have to find out the length of the side AD or DA by using the distance formula, that is x2 minus x1. That is minus 1 minus minus 3. Minus minus 3 is plus 3. So minus 1 plus 3 the whole square plus y2 minus y1. y2 is minus 2, y1 is 0. So minus 2 minus 0 the whole square. Next minus 1 plus 3. Minus 1 plus 3 is 2 square. Minus 2 minus 0. Minus 2 minus 0 is minus 2 square. Go for the calculation, that is 2 square is 4. Minus 2 square also 4. So finally 4 plus 4 we have got. So 4 plus 4 is equal to root of 8. Then root 8 we can split into 4 into 2. 4 is a perfect square. So perfect square 4 will come out as 2 out of the square root. Then inside the square root there is a 2 balance, so it remains as root 2 units. So finally the length of dA we have got 2 root 2 units. All the four sides are over. Now we have to move on to the diagonals BD and AC. So first of all we will calculate the length of BD, diagonal BD. That is, we have to write down the points B10, D minus 3, 0. As before, x1, y1, x2, y2, just we have copied down from the points. Using the distance formula, we can calculate the length of the diagonal BD. Length of the diagonal BD is equal to root of x2 minus x1. x2 is minus 3 minus 1. Minus 3 minus 1 the whole square plus y2 minus y1. So y2 and y1 both 0. 0 minus 0 the whole square. That is equal to root of minus 1 minus 3. Sorry, minus 3 minus 1. Minus 3 minus 1 is minus 4. 0 minus 0, that is equal to 0. Finally, minus 4 square we have to get, that is 16, plus 0 square is 0. Finally 16 plus 0, that is equal to root of 16. We know that root of 16 is 4 units. That is the length of the diagonal BD. Next we have to go for another diagonal, that is AC. For that we have to write point A and point C. Just write down x1, y1, x2, y2. Go for calculating the length of the diagonal AC by using the distance formula, that is x2 minus x1 minus 1 minus minus 1. So minus minus 1 is plus 1. Minus 1 plus 1 the whole square plus y2 minus y1. y2 is 2, y1 is minus 2. So 2 minus minus 2. Minus minus 2 is plus 2. 2 plus 2 the whole square. Calculation part, that is minus 1 plus 1. Minus 1 plus 1 is 0. 2 plus 2, that is equal to 4 square. Then 0 square is 0. 4 square is 16. 0 plus 16 we will get as 16. Then square root of 16 we know that it is 4 units. So finally we have got both the diagonals. Now it's time to conclude. So all the four sides we have got the same length, that is AB, BC, CD, DA, all we have got 2 root 2 units. And also the diagonal calculating time, the diagonal BD and AC also we have got the same, that is 4 units. Since in a quadrilateral all four sides are equal and the diagonals are also equal, therefore we can conclude that the given points are the vertices of a square. Now move on to the second question. The points 4 pairs are given to you here. First and foremost thing, as before, we have to draw a rough diagram and label it as ABCD or any other alphabet which you feel to put. Then after drawing the rough diagram, just assume the points. So let the points minus 3, 5, 3, 1, 0, 3 and minus 1, 4 are representing the vertices A, B, C and D of the given quadrilateral respectively. Just same as before, only the points are different. And we have to use the distance formula, that is root of x2 minus x1 the whole square plus y2 minus y1 the whole square. The first two steps are same for all the question, only the points will be changing. Next, from the diagram we can pick and write the points A and B because we want the length of the side AB. So after writing the points, just write down x1, y1, x2, y2. Then using the distance formula we can calculate the length of AB, that is a root of x2 minus x1. x2 is 3 minus minus 3, so 3 plus 3 will come, plus y2 is 1, y1 is 5, so 1 minus 5, y2 minus y1. Calculation part, that is 3 plus 3 is equal to 6, 1 minus 5 we get minus 4, so 6 square plus minus 4 the whole square, that is equal to 6 square we know that it is 36 minus 4 square we know that it is 16. When you add 36 and 16 you will get it as 52. So 52 we have to split as 4 into 13. You can just simply go for factorization, then you can come to the conclusion 52 is 4 into 30. 4 is a perfect square. Take when 4 comes outside the square root, it comes as 2. Inside the square root only root 13 balance. So final answer is 2 root 13 units. That is the length of AB. Next we have to go for calculating the length of BC. For that, write down B and C. Then we have to go for x1 y1. Next we have to go for x2 y2. Calculate the length of BC by using distance formula. X2 minus x1. So x2 is 0, x1 is 3. So 0 minus 3 the whole square plus y2 minus y1. y2 is 3, y1 is 1. So 3 minus 1 the whole square. Calculation part. 0 minus 3 is minus 3. 3 minus 1 is 2. So minus 3 square plus 2 square. Calculation. Minus 3 square will come as 9. 2 square is same as 4. When you add 9 and 4, you will get it as root of 13. So root 13 unit is the length of the side BC. Next we have to go to CD. From the diagram we can move from C to D. Write down the points C and D. Then copy down x1, y1, x2, y2 from the points. Then use the distance formula to calculate the length of the side CD. Length of the side CD is root of x2 minus x1. x2 is minus 1 minus 0. Minus 1 minus 0 the whole square plus y2. y2 is minus 4. y1 is 3. So minus 4 minus 3 the whole square. Calculation again. Minus 1 minus 0 that is minus 1. Minus 4 minus 3 that is equal to minus 7. So minus 1 square plus minus 7 square. That is equal to minus 1 square we have got as 1. 7 minus 7 square is plus 49. So we will get the answer as root 50. Root 50 we can split as 25 into 2. As I said before, if you feel difficulty to split, go for factorization. Then after factorization you can just combine it. 25 as 1 and the balance is 2. So 25 is a perfect square. 25 when it come out of the square root it becomes 5 and 2 inside the square root remains the same. So 5 root 2 units is the length of the side C. Next, from the diagram we have to go for calculating the length of AD. For that we have to write the points A minus 3 5 and D minus 1 4. Write down the coordinates x1 y1 x2 y2. Then we have to go for calculating the distance AD by using distance formula, that is root of x2 minus x1. So x2 is minus 1, x1 is minus 3. So minus 1 minus minus 3. Minus minus 3 is plus 3. Minus 1 plus 3 plus y2 minus y1. y2 is minus 4, y1 is 5. So minus 4 minus 5 the whole square. Calculation part. Minus 1 plus 3 is 2. Minus 4 minus 5 is minus 9. So 2 square plus minus 9 square. Calculation again, that is 2 square is 4. Minus 9 square is 81. So 4 plus 81 is equal to root of 85 units. That is the length of the side AD. So now we have to come to the conclusion by analyzing the 4 sides. So when you analyze the 4 sides, length of AB, length of BC, length of AC and length of AD are different. Means AB not equal to BC not equal to AC not equal to AD. So here we can stop calculation. No need to go for calculating the diagonals because the 4 sides are there, they are not equal. So here itself we can go for the conclusion. So before going for conclusion, let us have a visualization of the given points in a coordinate plane. So the given points I have marked in a coordinate plane. Here is the point A, that is minus 3 5, and here is B, that is 3 1, and this is C, that is 0 3, and here it is D, that is minus 1 minus 4. So after plotting these points, when you look at the points A, C and B, that is A, B, C, these 3 points are lying in a straight line, means A, B, C are collinear. So there is no way to form a 4-sided shape or a quadrilateral because 3 points are already lying in a same straight line. So we can come to the conclusion that the given points do not form any quadrilateral. Hope it is clear. And one more thing, this part, this visualization is only for understanding purpose. You no need to just write it as a part of answer. Now let's move on to question number 3. There are 4 sets of points are given to you. You have to verify whether these points forms any special type of quadrilateral or not. And as we are familiar with this type of questions, please try this question at home as homework. And question number 7, question is, find the point on the x-axis which is equidistant from 2, -5 and -2, 9. Let us have a visualization of this question. So there is a point on the x-axis, and as you know that the general form of any point on the x-axis, that is x0, means only x value will be there, y value will be 0, and I have labeled that point as A. And there is one more point mentioned in the question, that is 2 - 5, that is I have taken as B here. And the last point which is mentioned in the question, that is -2, 9, I have taken as C, that is here. And it is mentioning here in the question the distance AB and AC, they are equidistant. Equidistant means the length of AB and the length of AC are same. That is the question. If this condition is satisfied, then we have to find the value of x. That is what our question. So let us go for answering the question. So since the point on the x-axis, the coordinates are x and 0, x comma 0, that is a general form. Then we have to label that points as A, B and C. A x0, B 2 - 5 and C -2, 9 are the points. Now we have to go for calculating AB. I am not going to write any formula here, just a direct substitution. X2 minus x1, that is 2 minus x. X2 is 2, x1 is x. So 2 minus x the whole square plus y2 minus y1, that is y2 is -5 minus 0 the whole square. Go for the calculation, that is 2 minus x square remains same. 5 minus 0, -5 minus 0 is -5 only, -5 square is 25. You have to move to calculate AC. AC is equal to root of A is here, C is here. X2 minus x1, that is -2 minus x the whole square plus y2 9 minus y1 is 0. So 9 minus 0 the whole square. Go for the calculation. -2 minus x the whole square plus 9 square is 81. So they are telling that it is equidistance, means AB is equal to AC. Both are having the same distance, means AB we have calculated. This is the one, that is root of 2 minus x the whole square plus 25. It is written here, that is equal to AC also we have done here, that is root of -2 minus x the whole square plus 81. Both the sides square roots are there. You have to eliminate. For that you have to go for taking square on both the sides. When you take the square, what will happen? The square root will go. Means this becomes 2 minus x the whole square plus 25. Here also -2 minus x the whole square plus 81. Square root is gone. Now we have to go for a little bit of arrangement, because here variable is on the right side. For easiness of our calculation, this 2 minus x I have written as x minus 2. Both are same. Since the square is there outside, if you take a minus common, it is not a problem. So 2 minus x I have written as x minus 2 the whole square, because square is there outside, no problem of changing the order. Plus 25 equal to, here also one minus if I take outside, both becomes plus, that is x plus 2 the whole square. Since square is outside, even minus taking also no change. So x plus 2 the whole square plus 81. Once again, from here I have taken one minus outside, so I can take minus and there will be no change of value because square is there outside. So it becomes x minus 2, and here I take a minus outside, both minus will go off and it becomes plus, that is x plus 2 the whole square plus 81. So we know the a plus b the whole square formula, that is a square plus 2ab plus b square, and one more formula is there, that is a minus b the whole square, that is a square minus 2ab plus b square. By using that formula, we have to expand this one. A square, that is x square minus 2ab, 2 into x into 2. So 2 into 2 4, 4 into x is 4x. Then b square, that is equal to 2 square is 4 plus 25 same equal to x plus 2, a plus b the whole square, a square, that is x square, 2ab, 2 into x into 2. So 2 into 2 4 into x, that is 4x plus 2 square is 4 plus 81. So go for the calculation. both the side x square is there, that is cancelled. Again one more 4 is there, that is cancelled. And then final, the balance one we have to write. That means here one minus 4 is balance, and here one 25 is balance, that is minus 4x plus 25. And here one 4x balance, 181 balance. Just write down here. Then rearrange it, that is this 4x bring to the left side, that becomes minus 4x. So here one minus 4x is there, minus 4x is equal to 81 is on the right side, this plus 25 go right side means minus 25. So 81 minus 25, minus 4 is minus 8x, 81 minus 25, it becomes 56. So x is equal to 56 by minus 8. The final answer we have got for x is minus 7. So that is the answer. Therefore the point is x0 was our assumption. So x we have got now, that is minus 7. So the point is minus 7 0. So hope it is clear. Now we shall discuss question number 8. The question is, find the values of y for which the distance between the points p 2 minus 3 and q 10y is 10 units. Let us have a visualization of this question. There is a point p 2 minus 3 and there is another point q 10y, and the distance between p and q is 10 units. This is what the question. So we have to find out the value of y, and condition is the distance between p and q is 10 units. So go for solving the question. We know that the distance between the 2 points is given by the distance formula, that is the root of x2 minus x1 the whole square plus y2 minus y1 the whole square. Then the distance between the points p2 minus 3 and q10y is 10 units, it is given to you. So that means pq is 10. Just to go for calculating pq. Pq is x2 minus x1, that is 10 minus 2, 10 minus 2 the whole square plus y2 minus y1, here y2 is y minus 3, so plus 3, y plus 3 the whole square, that is equal to 10. Then just 10 minus 2 is 8 square, y plus 3 the whole square remains the same, that is equal to 10 units. Then we have to remove the square root. For that you have to square it both sides. Squaring times square root will go, 8 square is 64, y plus 3 the whole square remains the same is equal to 10 square, it will go to 100. Just y plus 3 the whole square is equal to this 64 will go to the right side, that is 100 minus 64, 100 minus 64 is 36. So y plus 3 we have to take, square will go to the right side, it becomes square root, that is square root of 36. So y plus 3 is equal to square root of 36 is plus or minus 6. So there is a plus value as well as minus value. So y plus 3 is equal to plus 6 or y plus 3 is equal to minus 6. So the first case y is equal to 3 will go to the right side, that is 6 minus 3, that is equal to 3 units. And in the second case y is equal to this plus 3 will go to the right side, that is minus 6 minus 3, that is equal to minus 9. That means the values of y are 3 or minus 9. Hope it is clear. Now move on to question number 9. That is, if q01 is equidistant from p5 minus 3 and r x6, find the values of x. Also find the distance qr and pr. So please try this at home as homework. The last question of this exercise, question number 10. Question is, find a relation between x and y such that the point xy is equidistant from the point 3, 6 and minus 3, 4. Let us have a visualization of this question. There is a point xy, I label it as P, and another point 3, 6 I have taken as A, and one more point that is minus 3, 4 I have taken as B. According to the condition, P to A distance and P to B distance, that means PA and PB are same, equidistant. That is what the question. So let the point P xy, I have just simply labeled the point P, and another point I have taken as A and another point is B. So let the point P xy be equidistant from the points A 3, 6 and B minus 3, 4. Then according to the given condition, PA is equal to PB. So let us take the distance formula and apply it here. That is x2 minus x1. PA I am taking. PA I am taking time. See, P here is having variable x and y. So I want to take this x, y first. Okay. So I'm just changing the order. The P, x, y and A36 I am taking. X2 minus x1. So here this one I am taking x2. So x2 is x minus x1, that is 3. So x minus 3 the whole square plus y2 is y minus y1, that is 6. So y minus 6 the whole square equal to PB. In PB also I am taking this one as first. Okay. So P is here, B is here. So x minus 3, x2 minus x1, that is x minus 3 the whole square plus y minus 4 the whole square. So for the calculation, that is x minus 3 the whole square plus y minus 6 the whole square equal to this minus 3 becomes plus 3 plus y minus 4 the whole square as it is. For removing the square root, we have to square on both the sides, that is square root is removed, x minus 3 the whole square plus y minus 6 the whole square equal to x plus 3 the whole square plus y minus 4 the whole square. Just to have a quick recall about a plus b the whole square, that is a square plus b square plus 2ab, and another here a minus b the whole square, that is a square plus b square minus 2ab. Apply it here. A minus b the whole square, that is a square is x square, 2ab, that is 2 into 3 6, 6 into x is 6x plus b square is 3 square, that is equal to 9. A minus b the whole square, a square is y, that is y square, then here 2ab, that is 2 into 6 is 12y plus 6 square is 36. On the right side also same, a square is x square plus 2 into 3 is 6x, then 3 square is 9. Again here a minus b the whole square, a square is y square plus 2ab minus 2ab, that is 2 into 4 is 8 minus 8y, then 4 square, that is equal to 16. So for cancelling the like terms on both sides, x square is cancelled. Again one more 9 both sides it is cancelled, and y square on both sides it is cancelled. So the balance I am rearranging, means one side constant, another side variables. So here 136 is there on the left side, that I am keeping, and on the right side I am bringing plus 36 to the left, that becomes minus 16. Sorry, right side 116 I am bringing to the left side, that becomes minus 16 equal to right side there is a 6x, same thing. On the left side there is a minus 6x, this one bringing to the right, so minus 6 becomes plus 6x. And here left side there is a minus 12y, bringing to the right side, that becomes plus 12y. And here on the right side there is a minus 8y balance. So I just rearranged constant one side, variables another side. That's what I have done. Go for the calculation, that is 36 minus 16, that is equal to 20, equal to 6 plus 6, that is equal to 12x, 12 minus 8, that is equal to 4y. Here there is a 4 common, divide it. When you divide 4 with the 20 it becomes 5, and divide 12 with 4 it becomes 3x, divide 4 with 4 you will get 1y. So 3x plus y equal to 5. So simply make an equation, that is 3x plus y plus 5, bring to the left side, that becomes minus 5 equal to 0. So this is the relation connecting x and y according to the question. Dear students, in today's session we have revised the basic properties of quadrilaterals and also learn how to prove the given set of points forms a special type of quadrilateral. In the examination point of view, it is a very easy as well as important chapter, so please go through the video from first to last and solve all the questions independently, and also solve the homework questions. And if you feel any difficulty or any inconvenience, please feel free to call. Thank you for watching.